Hey folks, welcome to this session where I'm going to share with you 10 weird facts about null in Java. Okay, let's get started. So weird fact number one is that null in fact has a special type, but it's not an object. So remember, null is not an object in Java, but it has a special type. So just to prove it, we've got this bit of code here, which doesn't compile, but we're going to go ahead and run it anyway. Okay, as you can see, IntelliJ can actually run the code even though it doesn't compile. And as you can see, we get something called a null type. So it's in special brackets because that's probably not its actual name. We don't know what its actual name is. It's a special type that we can't refer to in any way. We can't use, we can't instantiate. Okay, we can just use the null literal. But when we call toString on it, we get this error and it specifically mentions null type. Okay, so weird fact number one is that null has a special type, but it is not an object. Okay, let's look at weird fact number two. So completely different types look like they're equal if they are null. So let's run this. Okay, and as you can see, we have a list and we have an array list. One is called L, one is called I. They're completely different object references, but they both are null. Now, when we say L equals I, you'd think they'd be different because they're different types, but in fact, because they both point to null, they are equals true. Okay, that's weird fact number two, that even different types look equal if they are null when you use equals. Okay. Okay, weird fact number three, null equals null is true. Okay, just to prove it, we'll run that. Okay, that shows that it's true. Now, at first glance, you might think, well, actually, that's not that weird. But just bear in mind that you could have multiple references, as we spoke about in weird fact 2, that all point to null. And what this shows is that null is almost like a singleton, in which case all these null references are kind of pointing to the same thing because null itself is equals to null. So that's weird fact 3. Okay, now let's take a look at weird fact number 4. Null is not an instance of anything. Now, instance of is an operator in Java which allows you to check if an object's class is an instance of something else, okay, of another class. So the reference type here we have is a string, which is assigned null. String S is assigned null, okay? When we check S is an instance of string, you'd expect it to be true because the reference is of type string. This is checking the underlying object. Okay, so what this proves, if we run this, is that the underlying object, which is null, is not an instance of string. Maybe not that surprising, but it's interesting to know anyway. Okay, now let's take a look at weird fact number 5. Now, null is not even an instance of null. In the previous item, we saw that null isn't an instance of any class type, but what about null being an instance of null? Surely this must be true. Well, unfortunately, we can't even check because it just errors. You get a compiler, you cannot even run this. Okay, so null, despite, as we saw earlier, it has a special type, it's not in fact an object, and it's not an instance of even null. So that's weird fact number 5. Okay, now let's have a look at item 6. Casting a null does nothing. So here we have a string, and we assign it null, but we cast the null to string. Okay, now let's run this and see what happens. You can see in the first example, it prints out null followed by example, just as we appended it there. Okay, so the fact that we cast it to a string doesn't appear to have made any difference. And in the subsequent one, we call a method on SX, which is a string, which is assigned null. We want to see if the cast made any difference. And in fact, it made no difference. We still got a null pointer exception, the bane of many Java developers' lives. So why did that happen? That happened because SX is still null and you can't call a method on a null. Okay, so weird fact number 6 is that casting a null that has no effect whatsoever or no useful effect whatsoever. And in fact, IntelliJ is telling me that it's redundant. I could just get rid of it. So that's weird fact number 6. Okay, now let's take a look at weird fact number 7. Weird fact number 7 is that you cannot cast anything to a null. You get a compile error. The compile error isn't particularly helpful, but it means that you can't cast something to a null. If you have an object type, you cannot convert that to a null. You have to actually drop it. Okay, so that's weird fact number 7. Okay, now let's take a look at weird fact number 8. So this is perhaps the weirdest of all. You can in fact call a method on a null reference if it's static. So just to prove this, we've got a class here called static. It's a static class and it has a static method which prints hello. If we come back here and we try and call that method, we don't get a compile error, but we might get a runtime error, typically if we were calling an instance method. So let's just run that and see what happens. It's absolutely fine. Now this is null. So how on earth did we manage to call a method on a null? Well, static methods are actually class scoped. That means that all that Java needs is the class. It doesn't need an instance of it to actually exist. And that's what this means here. This means that there's no instance, okay? There's no instance of the class static. You can call the method anyway because you don't actually need an instance. It's class scoped. So that works absolutely fine. The weird fact number 8 is that you can in fact call a method on a null reference if the method you're calling is static. Okay, weird fact number 9. Now, unboxing a null causes a null pointer exception, not just calling members on a null. Now you know that if you have an integer I equals null and you try and call methods like I.int value, you know that will cause a null pointer exception because I is null. However, what happens if we try to unbox it? So here we're taking an integer and we're putting it into an int. And now we know that ints default to 0. They have default values. So maybe this mechanism would default. Let's run it and see what happens. you get a null pointer exception. So weird fact number 9 is if you try to unbox a wrapper, which points to null, you will get a null pointer exception because internally it's trying to extract the value and the object is null, so it can't extract the value. So you get a null pointer exception. Okay, and finally, we're on to weird fact number 10. You cannot synchronize with a null. So synchronization is about limiting the access to a piece of code to one thread at a time for some clunky thread safety. And this takes an object normally. So you might say something like, okay, and that's absolutely fine. But you try and put a null in there and it's not happy, you get a compile error, which is required object provided null. So that wraps up our 10 weird facts about Java. The last one was you cannot synchronize with a null. Okay, so I hope that was interesting. If you have any comments or feedback, just leave it in the comments below. If you know any other weird facts about null, definitely share those below. I'm sure other people would love to hear about them. Okay, thanks for watching.